Hello everyone, I'm Hadil, and today we're going to use a sine wave to offset the grid and animate it. I love grids because they're very versatile. They look very uniform and very boring sometimes, but with generative art you can play around with grids so often. I mean, if you look at your computer screen, it's basically a grid of pixels. So I think there is a lot of things that you can use grids with. And today we're going to animate it in a fun way using a sine wave. So let's start with a basic grid. I'll just put it in the setup section for now because we're not going to need it to animate at the moment. And because I want to show you a different way to create a grid rather than nesting for loops. So we're going to use just one loop, and we're going to deal with the area because with sine grid, or what I call sine grids, I want to play with the size of the rectangles separately instead of by rows or columns. And to do that, I'm just going to write a normal for loop, and instead of I, I'll just use n because I'll use I and j later. And I'll make it less than the area and increment like normally. So let's define the area. An area for any rectangle is width multiplied by height, so the number of columns multiplied by the number of rows is going to give me the area or the count of all of those rows. I mean, simple multiplication. So I'll just do integer count, so that's the row count and column count. And since I'm just doing a square for social media, for Instagram specifically, then I'll just do one count, but you can do X and Y if you want to. And let's start with a simple one, 10, because it's a multiplier of 800. And then I'll do area, which is going to be count multiplied by count. And now we're going back to this for loop, and we can do our I and the j. So for I, which is going to be the width, meaning our columns, it's going to be n modulo count. So basically it's going from 0 to the count every time and then going back to 0 to the count for every, and the rows are going to be j. So j is just going to be the area divided by the count. So it gives us the number of rows that we need based on the area, based on the count that we have. And then I'm going to create a p-vector. You don't have to do a p-vector, you can just do two floats, an x and a y. But I prefer p-vectors because they're shorter to use. I mean, they're not necessary. We'll just call it position. Position is going to be a new p-vector, and it's going to be I multiplied by the width and j multiplied by the height. So a normal positioning for any grid. So we're not doing anything different. We defined the I and j, we're just using the area instead of doing two loops. And now we define the width and height. So I'll just make those floats. So that those are basically the rectangle width and height, or the cell width and height. So you can just call it cell width and cell height. But I'm just going to call it width and height because I'm not going to use anything other than our grid. And our cell width is going to be width divided by count. I'm going to convert it into a float. And by the way, I don't know why after a division it just doesn't color it, but it still works. So it's still cast it into a float. And then height is going to be height divided by count again. And of course you don't have to use the height because it's a square, so it doesn't really matter. Now if I draw a rectangle or a square for each of the cells, it should work fine. So now I will do rect or square, and I'll do position.x and position.y, and then width and height. And because squares or rectangles are drawn from the corner, you don't need to push it like circles to the center. So if I draw a circle at position.x, position.y, and then the width, you're going to have to push it. So I'm going to have to do width divided by 2, and then height divided by 2. So it fits in the center. Or you can do ellipse mode, which is going to put it in the center, and just make the ellipse, the mode of the ellipse, or how you want to draw the ellipse, to be from the center. And you can also change this for the rectangle if you want it to be drawn from the center, and I think we're going to do that later. But for now, all I need is to see the grid. And I want to show you something when it comes to nested for loops. I want to show you the difference between a nested for loop and this loop. So I'm going to just quickly write this and come back. So running this, it's going to give us the same results. The only difference is that if I draw a text or write down the positions, so let's say I'll write down the positions of I at position.x or the values of I at position x and y. The fill is white, so it's actually drawing it. And I'm going to have to remove the rectangles. Okay, so as you can see, it goes from 0 to 9, and then it goes back from 0 to 9 for every row. And then if I do J, it's going to show me the columns. So it's going to go from 0 to 9 downward. And there is the 0 up here, but because we need to push it, so we have to push both width and height. But as you can see, it goes from 0 to 9. So the difference that I wanted to see, so for this other loop that we did, if I draw the text at n, and then position.x, position.y, you'll see a very different value, or different values. And let's push it so you can see all of the values. So you can see it goes from 0 to 9, and then it continues up to 99. If I do +1, it's going to give me 100, which is basically the area for 10 rows and 10 columns. So 10 multiplied by 10 is going to give me 100. So this is exactly what I need, because when it comes to the sine wave, I don't want it to be the same exact thing for every row or for every column. I want it to go up and down, and then the wave is going to just continue. So it's going to give us a more interesting result. So this is our guide text. I'm going to leave it for now. We're going to have all black because our fill is black, so I'm going to change that. And we can later deal with the colors. Now is the fun part, playing around with the rectangle's width and height using the sine wave, or using the sine function. So what I'm going to do is offset the width and height, or change the width and height by the value of the sine wave. And a sine function requires an angle to work. So I'll create an offset over here. We'll make it a float. So I'm going to just do an x offset, and I'll use sine function. So I'll just use an angle that I'm going to call XA, and for Y offset I'm going to do YA, and I will define those up here, and then I'm actually going to draw this in the draw part because I want to animate it. So XA and YA are going to be incremented down here. And then I'm going to use the offset here and here. And I have to reset the background so you can see the animation instead of it drawing on top of itself. So I'll just do a white screen. Oh, I have to multiply this, not add it. Okay, so as you can see, it goes down and then it goes up on the other direction. To avoid it going up and hiding up here, I'll just add the absolute function. So I'll encompass this into inside of an absolute function, so we don't get negative values. And if I run this, you can see it's now faster because it goes just from 0 to 1 instead of from negative 1 to 1. But you can slow it down by going down here and incrementing the angle by a lower value. And now it's much slower. This is where you can start playing around with the values over here. So you can, and that's one of the reasons why I did a different offset for the width and height, because I want to, let's say, make this 0.09 instead. So now one is going to be faster than the other. So the change in the width is going to be faster than the height. You can also do 0.05, just going to slow it down. So it's up to you how you want to play around with these values. And you can also add more interest to this by adding a shadow. So as things move, you can just add something like this and adding an offset. So this will be a static value. You can call it shadow offset, just for it to be clearer. I'm going to just define it up here, and I will also color it differently. So I'll just do a black or a gray color. So I'll just do fill, maybe 100. And for this one, oh, by the way, we need this off here. Otherwise, this is not going to see it for the first one. And then for this one, the fill is just going to stay white for now. Now you can see it's a little bit more interesting. You can also constrain your X offset and Y offset. So let's say you don't want the width to go all the way to the end. So something like this. X offset is going to equal the constraint of X offset from, let's say, 0.3 to 0.8. This way, it's just going to go from 0.3 to 0.8, so it's not going to go all the way to 0 and then all the way to 1. And you can do the same thing with the Y offset, but I want it to go all the way. But now this is a little bit boring because everything is just moving the same speed and the same direction, and it's really not doing anything fancy other than just moving it or scaling it up and down. So a way for us to make this more interesting, and the reason why I'm using a different kind of grid where the count continues, is because I want this wave to go from small to higher. So I don't want them all to increase in size and decrease in size in the same manner. I want them to be also offset by a value of the sine wave. And I can do this by saving the positions and saving a different starting value for each of the rectangles, and then drawing them later. So I'll add a few arrays up here. So I'll do the first one for the positions, and then a second one for starting angles. So that's going to be a float, or an array of floats. And I'm just going to call it SA for starting angles. Again, it's up to you how you want to call it, because the code is yours to read and it has to make sense to you. And then later I'm also going to add an array of colors, because I want to have the colors change also depending on the sine, a sine wave. Not necessarily the same sine wave, but a sine wave. So I'm going to just call that col over here. And I'm going to grab a bunch of colors that I have. So I do have an array of colors. This is one of the reasons why I'm just calling this col. And these are colors because this is my palette. You can call it palette as well. I'm just used to this, so I'm going to use this. So we only have 5 colors. If you want to copy and paste them, you can pause over here. And now let's go over here. Oh, by the way, we have to define or initializer arrays. So I'm going to do, for position, it's going to be a new 3 vector of size area. And the same goes for all of these. And now instead of drawing these over here, well, for now we're going to leave it, but I'm going to just do N, and it's going to be, so all of these are going to be stored inside of our array instead of just drawing immediately. And then for the starting angles, I'm going to store a different value for each rectangle. So you can do random, so you can do random from 0 to 2 pi. Let's start with that, and then we can talk more about other ways we can start our angles differently. So for color as well, I'm going to do random for now. So I talked about this before in a previous video, but I'm going to explain it again just for anyone who didn't watch that video or any of my previous videos. So basically what I'm doing here is getting the index using a random value from 0 to the colors.length. But because we're casting it into an integer, since we don't have indices that are floats, we cannot put an index that is a float. It has to be an integer. Since we cast it here, it's not going to go up to colors.length. It's going to go to colors.length minus 1. So anything above 0 and less than 1 is going to be 0, and so on and so forth. So anywhere from colors.length minus 1 to colors.length is going to be colors.length minus 1. So it basically floors it down. So it's kind of like using the floor function. So now we're getting a random value from 0 to the last value in our colors array. So for this one, let's remove the fill for now, or we're going to leave it for the shadow. So I'm going to cut this out, and I'm going to draw it here inside of another for loop. And this as well. We'll also take our guides. So this has to be position at position n, or this variable at position n in the array. And then I'm also going to take these ones, the offset, down here, because we're only offsetting the width and height, which are already defined up there. And just remove every empty space. And this initialization of each of the arrays and storing the values is just going to go inside of the setup function because we only want it to happen once. So now we have all our positions, all of our starting angles, and all of this. So what we need to do here is take the starting angle and just do this, basically. So we're adding whatever that is. Oh, and by the way, you can just call it I. I'm just calling it N for it to make sense that it's the same length as this. So we're just adding the random angle, the random starting angle to this X and A. So now each one of the rectangles or the cells is going to have a different starting angle, and then we're incrementing that using the X angle and Y angle. And I'm also going to position X over here just to make it shorter for us down when we're drawing the rectangles. And I'll be adding the width, or half of the width, and half of the height to the Y, because I want it to draw from the center, because now the animation is going to the corner, and I want it to go to the center. So I'm just going to change rectangle mode over here to center. Now I can use position X down here and position Y for the Y value. So this is already interesting. Let's actually color it so it's even more interesting. I'm going to just do color and at the end position. so whatever random value it has. And let's also add the color to the background because white can be boring sometimes. So for the background, I'm using this beige color, and I'll just use that variable. Now if I turn on the text, I can make it black. Now it's nice to see the values in the back. It's just kind of a little bit more interesting to see the guides sometimes. Now let's see a different way to randomize or change the starting angle for each of the cells. So instead of just doing it randomly, I'm going to comment this out and just do it over here. I'm going to space these out so we don't get confused. So this time, let's do mapping of the values, let's say of I, from 0 to the area, or to the count rather, because that's the biggest value of I. And then let's do it from minus 2 pi to 2 pi. As you can see, it goes by the width, so from 1 over here, from 0 over here for I, up to the count, which is 9. So we have 10 cells across, and this is how you're actually seeing the wave. And the higher the count, so let's say you go up to 40, the more you can see the wave actually. So we'll go back to 10, and instead of doing I or J, so if you do J, it's going to be the same thing, but from up to down. But I wanted to go from one corner to the other, so from the top left corner to the bottom right corner. And I can do that by multiplying I by J and going from 0 to the highest value for that, which is the area. Now we're going from corner to corner, and that's more interesting. And if I increase the number of count, or the number of rows and columns, so let's go back to 40, then it looks even more interesting. Now let's make the color a little bit more interesting. Now for color, I'm going to create a different value for the index. So I'll do, let's say, a float for sine wave, and I'm going to do I plus J for that. You can add whatever you want for the angle, it doesn't have to be an angle. And then I'll do the index, I'm just going to call it II because I already have an I. And then I'll just do, because it has to be an integer, so I'm going to previously just cast it into an integer before I start. And then I'm going to map the value of the S float, the S variable, from -1 to 1, because that's the values a sine wave gives me, or a sine function gives me. It's the output. And then to 0 to colors.length. And because map sometimes goes beyond those values, I'm going to have to constrain it. So I'll just do from 0 to 4, or actually colors.length -1. This makes sure that it doesn't go above the last value for the index. And then I'm going to use II over here. And now I can run it. We can see that the colors are much different. They're also going from one corner to another. I'm going to also change the, just before we do anything because it's bothering me, it's too dark. Let's do the shadow to be just a beige color that is a little bit darker than the background, so it's a little bit more realistic, and let's remove all of these strokes. Okay, and let's also round the rectangles. So I'll do by, let's do 15, and also we'll do it for the shadow. So if you do 1, then you're rounding all the corners the same way. If you do 4, then you're going top left corner and then going right and down left. So that's basically the 4 values that you can add after the first 4 values. Now if I run this, you can see that it's more rounded. It's just nicer this way. So for some reason this is too much, and I think because I have also other offsets in my original code. We'll see what to do with that. So I'll just continue adding the offset, and maybe the colors are going to change based on that. Okay, now the next thing that I want to do is add a little bit more offset, because even now it's still a little bit uniform. So you can see that it's going in the same direction every time, and there is still room to improve this. So I'm going to improve it by adding an offset or random, not necessarily random, but an incrementing offset for X and Y, or rather for the angles of the X angle and Y angle. So I'm offsetting these two as well. So you can start by adding more values over here. I'm going to stop this because it's a little bit distracting. So I'm going to do UF and V, or U off and V off. And then I'm going to start them in here, just using any arbitrary value. I'm just going to use 1. And then down here, before I can use the angles, I will just do XA, and I'll map the value from, let's say, N to 0, from 0 to count plus the offset. So I'm offsetting the count. So it's kind of like adding a little bit more value on top of my maximum value that I want. And I'm going to do from 0.1. And the reason why I'm doing this is because for the first cell, the one in number 0 or 1, it's not going to be visible because 0, it's going to have the value of 0. So I'm going to just start it from 0.1. And then to pi, I'm going to multiply it by U offset plus V offset. So I'm also adding more than the maximum angle that I want. I'm adding those two values that are going to increment every time. And then I'm also, and these are all arbitrary values. I don't have a reason for why I'm using pi instead of 2 pi. It just doesn't, I just tried several things and I like this, look better. That's basically it. So for this one, I'm also going to count plus the offset, and then also I'm going to go from 0.1 again to 2 pi this time because I want it to be different from the one on top. I don't want them to be uniform. I'm trying to change that. And then I'm going to do the offset here, and then let's also add the offset. Also, these are still going to be uniform if you're going to increment them the same way. So you'll have to also play around with those values so you don't increment them the same way. So now if I go down here, and I'll just do U offset plus equal, let's do 0.005, so it's not that fast. And for V offset, let's do the opposite. Instead of adding, let's subtract. So I'm going to do 0.001. So as you can see, this area is slower than this part. So we're mapping the value from 0 to count, so from here to here. So this is going to be the slowest. So you're actually not seeing this moving. Neither this, but it's actually moving. It's very, very slow. And then as you go, because we're mapping it this way, as you go down here, it's going to be much faster. So if I do 0.1 for this one, you're going to see a difference. The only problem I'm having right now is the colors. I'm not sure what I did that made the colors not go all the way up. Oh, got it. It's called.length, not call.length. So this was much bigger. So it's as if the space was much bigger. Now we're seeing more colors. Now if I add even more grid cells, then I'll get a nicer looking wave. Well, this is not very nice because it's too big, but you can see it moving very nicely here. But because of the guides, the text is too big. So you can either make the text a little bit smaller, or you can just make the grid a little bit bigger, or the cells in the grid a little bit bigger. I think 12 will show me the values nicely. Yeah. And you can see it moving. So the offset, or what the offset is doing, is that it's creating a different sine wave that is kind of like rotating through all of these cells, but at the same time we still have these smaller sine waves inside of the bigger sine wave. What's fun about sine and cosine functions is that the more you add to the angles, and if you add also a cosine to this function, so if you add a cosine with a different value for angle, then you also get different results. So it's really fun because a sine wave isn't always uniform, so it doesn't always just go up and down. You can add another wave into it, and that way can have a variation of height in the wave. And I think that's what's fun about it. And you can play around with it. You can find different ways to animate something like this. I also did something different with it by offsetting the position and leaving the negative values. So let's say I want to leave the negative values over here, but because we're drawing it from the center, it's not really showing that much. So if I, let's say, move this, you can see a different result, and it's really fun to play around with it. That's all I have for you today, and I hope you have fun creating this, and hopefully you'll show me the work on Instagram. Talk to you soon.